Seawater analysis by Michaela, Savannah, Stormy, and Wendy. This is some of the equipment we used. We used a plastic container to collect our sample, a sucky dish to measure the visibility depth, and a water quality tester which measured the pH, temperature, and salinity. We collected at 4 different sites: at the Sulphur Dock, the Coast Guard Station, which did have the nicest looking water, Pelican Island, and Texas City Dike. In Texas City Dike, there were a bunch of power plants in that area, so I did believe that this would affect the water quality in that area. Seawater analysis part 1. This is some of the equipment that we did use. We also used 2 milliliters of salt water in each of our titrations. And our titrations were done using a CalCut indicator, which tells us if there are any magnesium or calcium ions in the water, and a calmanite indicator, which actually tells us the concentration of these ions. It's important to know if we have too much or too little of these ions in water, because it can affect marine life's ability to form and maintain their shells and skeletal systems. These are our results, and here is just to compare. As you can see, Pelican Island did have the most calcium and magnesium, with the Coast Guard having the least. I really did think that Texas City Dike would have the most, so that was a surprise. This means that the equal levels of ions at the sulfur dock create water hardness, which stress out marine life and can lead to organ failure and reproductive issues. And the Pelican Island, Coast Guard Station, and Texas City Dike all had extremely high or extremely low levels of these ions, which affect marine life and their ability to form and maintain their shells. This data matters because it's important we understand how these ions are getting into the water and how we can stop it. I believe it's important that we actually take care of our oceans and try to restore that balance to better protect our wildlife.
So for the seawater analysis part 2, we were in the lab, and we used the test tube rack, red litmus paper, a centrifuge, a watch glass, spatula, a scale, and a weight belt. So what was tested and why? In part 2, we used the red litmus paper, which would turn blue if there was NH4 present in the seawater sample. Then with the data from the silver highlights and the BASO4 recovered in part 1, we tested for NH4, and it would show potential pollution of seawater with ammonia. So testing for silver highlights and BASO4 shows the level of those chemicals in local seawaters, and it could potentially help scientists or chemists learn what goes on in our seawaters, or what type of chemicals are in the seawater, and what we could do to help the environment and help um, better the ecosystem for those marine species that live in there.
On this slide, we have the chlorine and sulfur levels recorded from the silver halide and barium sulfate precipitates. These values help us understand how much chloride and sulfate were present at each of the 4 collection sites. The Coast Guard station had the highest values, with 6,090 milligrams of chlorine and 1,618 milligrams of sulfur. There were also fairly high levels at the sulfur dock, with 5,640 milligrams of chlorine and 1,101 milligrams of sulfur. The Texas City Dike had moderate levels, with 1,425 milligrams of chlorine and 483 milligrams of sulfur. And the Pelican Island Cut had the lowest values of 510 milligrams of chlorine and 300 milligrams of sulfur. These results show that the sulfur dock and the Coast Guard station had the greatest concentrations of chloride and sulfate precipitates, suggesting a higher level of these ions in the surrounding water. So here we have a graph comparing how chloride and sulfate concentrations vary across the 4 sample sites. We can see that 2 of the locations, the sulfur dock and the Coast Guard station, had significantly elevated levels, and these spikes can be influenced by nearby industrial activity, shipping traffic, or even runoff that introduces more of these ions into the water. Pelican Island Cut, however, shows the lowest overall concentrations, which can just suggest that there is cleaner or less disturbed water throughout the area.
Alright, we've seen the data in the graph. Now, what does that mean? As you can see with the sulfur docks, the levels of chlorine are very elevated, and this can have negative effects on the respiration and immune system of wildlife in the area with prolonged exposure. And the Coast Guard station is very similar. It also has elevated chlorine levels, though a bit less so than the sulfur docks. Meanwhile, at the Pelican Island Cut and the Texas City Dike, you can see there is elevated calcium levels, which can cause stress on the wildlife as it changes the ion levels in the water. Then, also at the Pelican Island Cut, you can see some elevated magnesium levels here. The calcium is also kind of elevated, but our magnesium is quite elevated, which can have negative effects on wildlife skeletons and growth. It'll impact and give them birth defects with long-term exposure. Alright, so why does this data matter? The different levels of ammonium, barium sulfate, calcium, and magnesium show the effects that the nearby infrastructure has on the water in the channel. And the elevated levels of ammonia can have negative effects on sea life as it's toxic and can contribute heavily to eutrophication, which can create dead zones in the water. Elevated calcium levels stress the organisms as they're forced to adjust to different ion levels, as I mentioned earlier. Elevated magnesium levels disrupt the physiological processes, as I also mentioned. And then in the barium sulfate form, it can have negative effects on infrastructure as it contributes to scaling. And as we can see, those elevations are in small areas. So as long as wildlife isn't sedentary or in situ, it won't have too heavy of effect, but we need to make sure to keep it that way and continue controlling the effects of pollution from our local infrastructure. Thank you for listening.